Okay, now let us look at tutorial 1 question number 4. In tutorial 1 question number 4, you are given 4 points A, B, C and D. So the position vectors of these 4 points are on the board. For question 4 part 1, it is interested in the equation of the plane through A, B and C. So you can imagine it passes through A, B and C. So you're asked to find the equation of this plane in the parametric form. Again, first, second and third. Okay, to find the equation in this form, you need a first vector which represents a point on the plane. I could conveniently choose the point OA. The second one is a vector that is parallel to the plane. An easy choice would be the vector AB. How do you find the vector AB? The vector AB, right, is just OB minus OA. So I'm going to choose the vector AB. AB is definitely parallel to the plane. So AB is OB minus OA. You get 0, 1, 1. And then I need another vector that is parallel to the same plane. An easy choice would just be the vector AC. AC would be OC minus OA, and then 0, 0, 1. There we are for part 1, the equation of the plane through A, B and C in the parametric form. Now in part 2, we are asked to find the equation of a second plane that goes through the 3 points. In this case is what? Is A, B and D. A, B and D. Right? To find the equation of a plane in the dot product form, right? Scalar product form or the dot product form, you need to do this again. Step 1, you need a vector that is perpendicular to the plane, and then you need a number. To find a vector perpendicular to the plane, a convenient choice would be to take the vector AB cross AD. So maybe I should erase all of them first. I'm going to compute this vector n for part 2, right, by taking AB cross with AD, right? Because AB is parallel to the plane, AD is parallel to the plane, their cross product will result in a vector that is perpendicular to the required plane. So AB, what is AB? AB is OB minus OA, so it's 0, 1, 1. How about AD? AD is OD minus OA, so it's minus 1, 2, 2. So you want to cross product these two vectors. To cross product once again, you cover the first row, and then you get 0. You cover the second row, you get minus 1. To cover up the third row, you get 1. Alright, it's always good to check that it is correct by taking this, the dot product this, to get 0, on this, dot product this, must also give you 0. So there we are, a vector that we need, a vector that is perpendicular to the required plane. Then I can write down the vector of this equation as r dot 0 minus 1, 1 equals. Alright, how do you find this number? To find this number, right, I need to take a point on the plane. I can use either A, B or D. Anyone doesn't matter, it will be the same. The dot product with the vector n. So if I take this dot with this, right, I'll get the value 1. You try, say you take the point B and you dot product with this. Again, you get 1. You try, you take the vector D and dot product with this. You will still get 1. So that assures you that to find this number on the right, you can take any of the points to dot product with n, and you should get the same number. And there we are, the equation of the plane ABD in the dot product form. Part 3 wants you to find the equation of the plane ACD. So maybe you draw a diagram. A, C, and D. Right? You want to find the equation of the plane ACD, in this case in the Cartesian form. So to find the equation of the plane in the Cartesian form, we have to go through the dot product form first. So for the part 3, I intend to find the vector n by taking AC to cross product with AD. Right? AC is parallel to the plane, AD is parallel to the plane. The cross product will be perpendicular to the plane. AC will be what? 0, 0, 1. 0, 0, 1. Cross with AD. AD is minus 1, 2, 2. You cross product these two vectors. You get, again, cover the first row. Cover the first row, you get minus 2. Cover the second row, you get minus 1. Cover the third row, you get 0. Right? So this is my vector n for the plane ACD. So I can say that this will be r dot minus 2 minus 1 0 equals, to find the number on the right, I can take any of the point A, C, or D. So if I choose to take the point A, the dot product with this, I get minus 2 plus 1, it gives me minus 1. Right? Then to convert now into the equation of the plane in the Cartesian form, this would be minus 2x minus y equals to minus 1. There's no z. You know why there's no z? Because the third one is a 0. If you write this as x, y, z, when you perform the dot product, the z doesn't appear. And this equation could even be reduced nicely. If you multiply by minus throughout, you get 2x plus y equals to 1. It's equivalent, the same. Okay, it's the same. Right? This is equation of the third plane A, C, and D in the Cartesian form.